Again, these lectures cover the regression. In our previous lectures, we covered the correlation. So our main objective is to learn how to find the equation of a regression line, also to predict Y values using regression equation. Now, after we verify that the linear correlation between two variables is significant, next we can determine the equation of the line that best models the data. And now in our previous lectures, we learned how to find the PSE correlation coefficient, the R value. The R value is between -1 to +1. And that will determine if there's a relationship between the two variables. If the value is very close to 0, it means there's no relationship. If it's close to -1 or it's -1, then we have a negative relationship. If it's close to +1 or it's +1, then we have a positive relationship. So first, before we do a regression or we find a regression equation, first we need to determine if there's a relationship between the two variables, in this case, X and Y. Next, we want to know what is a residual. A residual is the difference between the observed Y value and also the predicted Y value for a given X value on the line. So a residual will be more or less an error. So if the predicted Y value is the same as the observed Y value, then the residual is 0. So again, residual will be the difference between observed Y value and predicted Y value. So from the diagram here, we can see the straight line will be our regression line. And all the points on that line is the predicted Y value. And the observed Y values is the blue dots. So the difference between the observed and the predicted, again, will give us the residual. Now, the regression line, which is the line of best fit, is the line for which the sum of the squares of the residuals is minimal. So which means our regression line should be very close to where most of the points are, or if possible, they should be on the line. The points should be on the line, which means a regression or the sum of squares residual will be 0. So that's the equation of a regression line, which is Y caret equal to mx plus b. Again, m represent the slope, b represent the y-intercept, and the Y caret is the predicted Y value for a given X value. So this is the formula to find the slope. N is the sample size. So the sample size N times the product of SY sum minus the sum of X times the sum of Y divided by N times S squared sum and sum X all square. So when we know the M value, we can find the B, which is the Y-intercept. The B will give us the Y average minus M times X average. So Y average will give us the sum of Y divided by N. And also the sum average or the sum, the X bar or the sum of X will give us average X will give us sum of X divided by N. So that will give us the M and B. Then from there, we can be able to again plot in the value. Here we are finding the regression equation manually. But again, the future we're going to use the Excel or JAVS to do it. So to find the equation of a regression line for advertising expenditures and the company sales data. So we want to see if there is a relationship between the amount a company spends for advertising and also the revenue that they generate or the company sells. Here we have some sales data for some few years and also the expenses. So we want to find out if there's a relationship. So the expenses will be our independent variable. So that's our X. And then the company sales will be our Y value because based on the amount the company spend on advertisement, we may know if it will affect the sales or the revenue that the company generates. So here we find the product of x, y, then later we sum everything. So the sum of x, y is given. We also need the sum of x and also the sum of y for our formula. And also we find the x square, the sum of x square, and also the y square individually, and the sum of y square. So now we can be able to plug the values in our formula. So we have the n times the sum of xy minus the sum of x times the sum of y divided by n, which is 8, times s square sum, and also the sum of s squared. And that gives us 50.72874. Then we can be able to find now the y-intercept, which will give us the average. We know the sum of y is 1634 divided by 8. That gives us the average. Minus the slope times the average of x, which again gives us 15.8 divided by 8. So after the calculation, we get 104.0607. So now we know the value of b and we know the value of m. So our equation predicted will be y caret equal to 50.729x plus 104.061. So from here, we can be able to predict any y value based on the x value. So in our next example, we also can use a technology to find the equation of regression line. Example, as we said, we can use Excel, etc. So example here is we want to predict y value if x is 1.5, 1.8, and 2.5. So first, when x is 1.5, this is what we get. We get 180.155. So all we need to do is to substitute x value with 1.5. When x is $1.8,000, we also do the same thing. Substitute x with 1.8. And the last one, 2.5, we substitute x with 2.5. And we get the predicted value of 230.88. So here we say predictions values are meaningful only for x values in or close to the range of the data. So the x values in the original data set may range from 1.4 to 2.6. So it will not be appropriate to use regression line to predict company sales for advertising expenditure such as 0.5 or 5.0. So that's the summary of this lecture. So in this lecture again, we learn how to find the equation of a regression line manually, and also we predicted y value using a regression equation. Again, thank you for your time and see you in the next lectures.